Okay, so for this is section 2.2 part 2, and here we're going to be talking about, we're starting from example 5 as a recap from the previous video. We basically just looked at let's see, here's a good one. We looked at the values of sine, cos, and tangent, specifically in different quadrants, and here's the golden slide that you have to commit to memory, right? You're going to have to know the correct values to place in for sine, cos, and tangent, okay, to be able to do these questions. We're on example 5. I skipped example 4, so maybe I'll just take a brief look at it. Example 4 was determining trig ratios of quadrantal angles. What that means is either at 90 degrees right here, at 180 degrees, 270 degrees, okay, or at 0 degrees or 360 degrees. Honestly, it's the exact same as before. Take a look at the solution. This time you're going to have zeros for x and y depending where you are. At 90 degrees, okay, at 90 degrees x is 0, right? You're at the origin. But y will be length y, of course, because you're right on the axes. R will also have that length. Okay, at 180 degrees, it will be the complete opposite. X will have length x, R will be length x, and y will be length 0. The only one you have to watch out for is at 270 degrees, tangent at 270 degrees, okay, and tangent at 90 degrees. You have to be careful, okay, because tangent is y over x. So, sorry, y over x, that's an x. So if x is 0, this is undefined. Okay, that's what you have to watch out for. Other than that, pretty straightforward. So, example 5 says solve for an angle given its exact sine, cosine, or tangent value. So, let's look at it. You can take a look at the example with the complete solutions. I'm going to take a look at the practice problem. Solve sine theta of -1 over root 2 between 0 and 360 degrees. What this means is you're going to have multiple solutions. You may and you will in this situation. The goal is to first find theta r. First find where you are on the Cartesian plane. Find out where you are. And how we're going to do this is we're going to take advantage of -1 over root 2, the negative sign, and this value. Where do you see this value before? Okay, it should ring a bell with this special triangle where you have 1, 1, square root 2, and 45 degrees. This is a 45 degree special triangle, right? Special triangle. So, using that, knowing r, theta r, comes quite quickly. Theta r is going to be 45 degrees, right? Because you can transpose this special triangle right onto here. At 45 degrees, you're going to have the following situation. You're going to have a 1 and a 1 and a root 2. But that's not what we have, right? We have sine is negative. Where is sine negative? Right? That's a good question. Where is sine negative? Is it negative in quadrant 2? No. Okay, remember the cast rule? The cast rule tells you where these things are positive. But it's not great to memorize the cast rule. You should understand what's going on. Sine really deals with y, right? Because sine theta is y over r. Okay, so if we're dealing with y and we have a negative value, remember r is always positive. So that would have to mean that we're dealing in quadrant 3 and quadrant 4, right? Because that's the only place where y is negative. Y is negative. Okay, so what we're looking at, I'll switch colors for this. We're looking at two solutions. Like that. Okay? Two solutions. You already know the sides, right? The sides will have to be 1 and 1. Okay? This time, what we're going to have is we are going to have -1 for x. You don't really have to care about x. All we really care about is y. -1 for y, root 2. What you really care about is what the heck is this angle right here, right? What's this angle right there? That will be one of the solutions. That will be one of the solutions. So let's figure it out, right? We know the reference angle here is 45. Bit messy, but you know the angle is 45. So you know it's going to have to be 180 degrees plus 45 degrees. Will come out to be 225 degrees. Okay, that's a 5. 225 degrees. Theta also, and that's in quadrant 3 by the way, theta also will be over here, right here, which will be simply 270 plus 45, which in this case, of course, will come out to be 315. That's quadrant 4. Those are the two solutions, actually, in this question. I want you to check right now. Go on a calculator and plug in 225 and 315. You're going to get a decimal expansion of roughly negative 0.7077071 ... Then plug this in and you realize that your decimal expansion is the same. Of course, we're looking for exact values. That's why it's very useful to go through a special triangle procedure to getting the solution to this. Okay? So, now that you know that, let's go and extend it to an approximate value, not an exact value. So an approximate value. So same deal, same type of question. You can look through the example there to get a work-through solution so you can read it. But here is exactly what I'm talking about. Determine the measure for theta to the nearest degree given sine theta is negative 0.8090, where we're between 0 degrees and 360 degrees. Alright? So, how does the situation change? Well, you can't use a special triangle, because you don't know anything about that value. Time to use a calculator. So, you're going to use a calculator to find the reference angle. Let's use a calculator to find the reference angle. The reference angle is the closest angle to the x-axis. So given if you had a terminal arm in quadrant 1, that would be the reference angle. So quadrant 1 is unique in the sense that no matter what angle you have in quadrant 1, wherever the terminal arm is, the reference angle equals theta in quadrant 1. In quadrant 2, that's not the case. Okay, that in quadrant 2, this full angle is going to exceed 90 degrees, but the reference angle, okay, will be smaller. It will be the one closest to the x-axis. If you plug in this value right now, exactly as it is in your calculator, if you solve for theta using the inverse sine function, which we're going to do, you're going to get a value that is potentially larger than 90 degrees, or it's going to be a negative value. But we're actually interested in what happens in quadrant 1. So what you're going to do is you're actually going to consider the positive situation to find theta r. To solve for this, theta r is going to be sine inverse of 0.8090. That's how you undo this function, is you use the inverse sine function. It should probably have a second function sine on your calculator. So I'm going to do that right now. Second function sine of 0.8090. That comes out to be 53.998. Okay, which will go to the nearest degree of 54 degrees. This tells you the reference angle, you guys, is 54. 54. Clearly that's not a solution, because sine of 54 gives you positive. It would give you positive 0.8090, but we want negative. So again, where is sine negative? Quadrant 3 and quadrant 4. You need to extend this picture to have one picture in quadrant 3 with a reference angle of 54 degrees, and quadrant 4 with a reference angle of 54 degrees. Those will be your two solutions between 0 and 360 degrees. For quadrant 3, we're going to have theta equals 180 degrees plus 54. And that will come out to be, of course, 234 degrees. For quadrant 4, we're going to do the same thing, except we're actually going to go 360 degrees minus 54. 360 degrees minus 54 comes out to be 306 degrees. Now, those are the two solutions. I suggest you check them. Let me just write this out. Sine, you're actually just going to go sine of 234, and that will of course equal, if you plug it in, right back to your answer. Do the same thing for the next one, and you're going to get the answer once again. That's how you check. You can always get these 100% correct, because you're always going to be able to check them to see if you got them correct. Okay? So hopefully that makes sense. The difference between example 5 and 6 is example 5, I used a special triangle. Before we exit the video, you actually can use one solution or one technique to rule them all here. You don't need this, because what you can do is you just can go sine inverse of positive 1 over root 2, which will pump out 45 degrees. There's your reference angle, and you can go ahead and keep going. I like using special triangles because it really gets rid of the calculator. But if you have a calculator, and if you want to have one procedure to rule them all, then you can do this, right? So, work on the practice problems, ask me if you have any questions. Hopefully this made sense, and we'll see you next time.